Hello, I'm Hugh Manfield, and welcome to another episode of What Einstein Got Wrong. Today we're going to be talking about rotations and how that relates to Einstein's foundations for his theory of general relativity. Now, Einstein was critical about Newton's analysis, so let me go through Newton's bucket. Now, Newton's bucket is a thought experiment that was conducted by Isaac Newton, and it has to do with rotations. And yes, Einstein did not invent the thought experiment. It actually probably goes back to the ancient Greeks. And probably the first documented case of it is some of the writings of Galileo. Anyway, Newton's bucket, an observer finds himself alone in a void. In front of him hangs a bucket on a rope. He looks up and he can't see in the distance what's holding the rope. All he sees is rope going on as far as he can see. And looking around, he can't see what's supporting the bucket, and he can't see what's supporting the floor that he's standing on. And he notices the bucket is at rest. The rope, the bucket, and the water are all at rest with respect to each other, and the surface of the water is flat. But presently, he notices that something is applying a twist to the rope, and the rope begins to turn, and the bucket begins to turn, and gradually the water inside the bucket begins to rotate along with the bucket due to the friction at the edges. And eventually, after a certain span of time, the water and the bucket and the rope are all again at rest with respect to each other. However, in this case, the surface of the water is dished due to the centrifugal forces acting on the water. Newton was perplexed with how can these centrifugal forces arise, because the bucket and the water and the rope are all at rest with respect to each other, and yet there are two different cases. And he concluded that rotation must be something that's absolute. The space of the bucket is stationary, and the bucket is rotating with respect to space. This is an example of the actual behavior of the natural world, yet Einstein found it was at odds with his chosen philosophy, his space denial philosophy, that he founded relativity on. And Einstein felt that this way of thinking undermined his theory of 1916. Now, Einstein's problem was that for reference frames in translational motion, there's no discoverable universal resting frame. One reference frame in motion is just like any other reference frame, and none can claim priority as being at rest. You can choose this one to be at rest, you can choose another one to be at rest. No matter how fast they're moving, no matter which direction, there's no universal reference frame for translational motion. However, this is not true for rotations. When an object is in rotation, there is only one rotation rate at which no centrifugal forces arise, and that's what we call at rest in rotation. These differences, he felt, undermined his equivalence principle. So to deal with this, Einstein worked with Ernst Mach on what is known as Mach's principle. Basically, Mach's principle is, if we have a row of reference frames, and here I've drawn wagon wheel space stations, and they're all on the same axis, and they're all rotating at different rates, there will be one station where the occupants are weightless throughout the station, and on all other stations they will feel various levels of gravity based on their rotation rate. The station that is at rest, where everyone floats weightless throughout the station, can claim, I'm the standard by which you measure your rotation rate, and you can all calculate your gravity based on this station as being the rest reference frame. So we'll look at a paragraph from Einstein's paper of 1916 entitled The Formal Foundation of Relativity. This is extracted from the English translation, which is available at Einstein Papers at princeton.edu. The original German language documents are there as well, and I presume that someone at Princeton has compared the two and agreed that the English translations are accurate. Otherwise, I don't think they would have posted it. Anyway, Einstein begins in this paragraph from his paper that at first glance it appears to be such an extension of the theory of relativity would have to be rejected on physical grounds. Well, that's quite a telling statement. He's saying that his theory of relativity looks like it should have to be rejected. And then he goes on, let there be a coordinate system K that is in the sense of Galilean Newton, and another sense K prime, which is in uniform rotation relative to the original reference frame K. So he's dealing with rotations here. And he can pick any reference frame K in any state of motion, and then you put a parallel reference frame to that that's in a state of rotation. And Einstein says centrifugal forces will then act on masses which are at rest relative to K prime, while those masses are at rest relative to K do not suffer such forces. And already Newton viewed this as proof that the rotation of K prime had to be interpreted as absolute. All right, so he's quoting Newton's bucket and how Newton said that rotations are absolute relative to space. Then Einstein continues, this argument, however, is not cogent, as shown by Ernst Mach. So he's quoting Mach's principle in the foundations of general relativity. And Mach says, this is because we do not necessarily derive the existence of centrifugal forces from a motion of K prime. Instead, we can just as well derive them from the average rotational movement of distant ponderable masses in the environment, but relative to K prime, thereby treating K prime as at rest. Okay, so what is he saying? He's saying that we can pick any of those rotating stations or any rotating reference frame and just declare it to be at rest, and it's at rest, and it's the universe that's rotating about it. Okay, so that's Mach's principle, and it's basically delusional thinking. So here's Mach's principle. I'm not rotating, it's the entire universe that's rotating around me. That's delusional thinking. Let's think about this a little bit more. Let's use reference frame K as the Earth at rest. And the Earth at rest, the sun will rise and set once a year, and the stars will have fixed positions in the sky because it's not rotating. And then we'll let K prime be the Earth that's rotating. And we'll see the stars track across the sky, and we'll see the sun rise and set each day, just as we do. So Mach's principle says, let's just declare the rotating Earth as being at rest, and it's the rest of the universe that's swirling around above it. Now, there's a name for that. Let me see, what was that? Oh, it was the Earth-centric model. That's right. And there was this fellow, Galileo. That's right. And he proved that it wasn't the heavens rotating around the Earth, but the Earth had to be rotating beneath a stationary cosmos. And he did this at great risk, and he had to go on trial for heresy for claiming that the Earth was not at rest. He spent the rest of his life in house arrest, but eventually the rest of the world came around to his point of view that indeed the heavens are at rest and the Earth is rotating. And this was seen as a great step forward in science. So what Einstein's saying in this paragraph, as long as we're willing to go back to the Earth-centric model and assume that the heavens are whirling around the Earth, then everything's fine with the foundation of general relativity. Okay, that's just delusional thinking, and it's bad science. But it goes on. He says, if the Newtonian laws of mechanics and gravitation do not allow for such an interpretation, it may well be founded in deficiencies of this theory. So he's already admitting that general relativity may have some deficiencies. Well, I can agree with that. Let's continue. The following important argument also speaks in favor of a relativistic interpretation. The centrifugal force, which acts under given conditions upon a body is determined by precisely the same natural constant that also gives its action in a gravitational field. Okay, so what he's saying in that sentence is that gravitational mass and inertial mass are the same. I've already dealt with that in my prior video as erroneous thinking, but he's using the concept that gravitational mass equals inertial mass to prop up his theory, and that's circular reasoning. But then he goes on, in fact, we have no means to distinguish a centrifugal field from a gravitational field. Now that is just an outright falsehood. Yes, it's a lie. There are many simple ways to determine the difference between a centrifugal field and a gravitational field. And I'll go through one of them right now. We have Ricky in a closed box in a gravitational field. And we ask Ricky to conduct some experiments to try and figure out whether she's in a centrifugal field or a gravitational field. So what Ricky does is she hangs a plumb bob from the ceiling down to the floor. And it hangs straight down. Now, that's going to be the same behavior whether you're in a centrifugal field or a gravitational field. So far, she hasn't learned anything. But the next thing Ricky does is she takes a similar weight, puts it a certain distance away from the string, and lets it drop from the ceiling. Now, in a gravitational field, it's going to drop parallel to the string, straight down to the floor. But in a centrifugal field, it's going to veer off to one side. And the direction that it veers is going to be a line in the direction of rotation. So if you draw a line from the point where the weight hits the floor to the line where the plumb bob matches the floor, that's going to be your direction of rotation. There are other simple experiments she can do so that she can not only determine that she is in a centrifugal field, but she can also tell her distance from the center and the rate of rotation. Now I'm going to leave that as a challenge for you out there to figure out whether you can actually do physics or only talk about it. Send me your experiments of how Ricky can determine her distance from the center of rotation and the rate of rotation, and I'll let you know if they're right. Mach's principle, he proposed that any of these stations at any rotation rate can be declared at rest, and then we just measure the rate that the universe is rotating around them to determine the centrifugal forces. And that's just backwards thinking. And it's also spooky action at a distance. And for this, I've awarded Mach the dunce cap. And let me explain why it's spooky action at a distance. Let's say we have Newton's bucket hanging in the void and it's in a state of rotation. However, there's no distant matter in the entire universe. The only thing is Newton's bucket. So, according to Mach, that bucket can't realize that it's in a state of rotation, and the water in the bucket will be flat. But then we move to frame B, and at some distance, which is unspecified by Mach, we introduce a bit of distant matter. And also the amount of distant matter is not specified by Mach in his principle. But when we introduce this distant matter, suddenly the surface of the water becomes dished for no apparent reason except the addition of the matter. And is it a light year away? Is it a million light years away? Is it 10 meters away? We don't know. But still, it's not local action. It's spooky action at a distance. We introduce a distant matter, and suddenly there are centrifugal forces. Let's go a little bit further. Let's say we have a space station, wagon wheel space station, out in the void. It's the only thing in the universe. There's no distant matter. So the occupants of the station build a small replica of their station, and they notice when they spin it, objects inside are thrown to the outside. And they decide this would be a nifty thing to have. We could have gravity instead of floating around weightless. So they equip their station with thrusters. Now I've drawn rockets, but they use light thrusters because they don't have any matter to lose. They have energy they can expend, but They want to hang on to all their matter they have because that's the only matter in the universe. So they turn on their light thrusters and they expect to experience centrifugal forces throwing them to the side of the station. But they find that they continue to float weightless because there's no distant matter. That's what Mach would tell you to believe. So in frame B, we introduce some distant matter, maybe a star winks into existence somewhere out in the distance, comes over the Hubble horizon, and suddenly everyone on the space station is thrown to the walls and they have gravity. Well, it's spooky action at a distance, and it's really like a cartoon, okay? It's like the coyote going over the cliff and not falling because he hasn't noticed that he's over the edge until he looks down and then he falls. So it's really bad science. So Mach's principle was never taken to the status of an actual principle or natural law. If we look at the three different forms of gravity, the three forms of gravity each represent a state of motion. We have a linear acceleration, or a state of changing motion. We have motion along a curve, constantly changing motion, and we have standing on a massive body. Now, most people think that when they're standing on the surface of the Earth, they're at rest. But the Earth is actually moving and rotating. So really, all of these represent an accelerated reference frame where you feel gravity and you're in a state of continuously changing motion. Now, within each of these reference frames, we can discover a rotational reference frame that is at rest. We can conduct an experiment, maybe with a little centrifuge, and we can watch and tell when things are hanging straight down and when it's rotating and they're thrown outwards. And we can discover that single rotational rest frame in any reference frame, which means that a rotational resting frame obeys the equivalence principle. Doesn't matter what reference frame you're in, you can still find it. It's the same physics happening in any reference. And this makes it rise to the level of where it could be considered a natural law, that there is only one rotational resting frame in any other reference frame, regardless of its state of motion. And it will actually be Lorentz invariant because it's such a simple case. It follows the principle of relativity. It's Lorentz invariant. It really could be stated as a natural law. And Werner Heisenberg, in his book, Physics and Philosophy, which I recommend you read, but it is rather deep and thick, so you better be prepared for a little exercise of your brain while reading it. And you probably can't do it all in one setting. Anyway, Heisenberg says, the existence of centrifugal forces in a rotating system proves, so far as the theory of 1905 and 1906 is concerned, the existence of physical properties of space which permit the distinction between a rotating and non-rotating system. He agrees with Newton. He continues, this may not seem satisfactory from a philosophical point of view, from which one would prefer to attach physical properties only to physical entities like material bodies or fields and not to empty space. And there he's describing Einstein's philosophical point of view. He only wanted to attach significance to material bodies and not to empty space. But Heisenberg continues, but so far as the theory of electromagnetic processes or mechanical motions is concerned, this existence of physical properties of empty space is simply a description of facts that cannot be disputed. And I agree with Heisenberg. So, we have Heisenberg and Isaac Newton, two influential pillars of physics, and we have Albert Einstein and Ernst Mach, and they're in contention with each other. Well, sorry Einstein, you've got a clunker on your team. I'm going with Heisenberg and Newton, and you should too. So this paragraph is full of inconsistencies, delusional thinking, and outright falsehoods, and it is the formal foundation of relativity. After reading this far in the paper, you should just set it down and say, this is rubbish. It's intellectual garbage. And, as we say, garbage in, garbage out. Any math that's developed on top of this, and Einstein went on in this paper and developed all sorts of fancy math, well, anything developed on top of this is going to be garbage, and there's no point reading any further. And yet, general relativity is enshrined as the pinnacle of physics to this day and taught around the world. And that needs to change. It's just wrong. It's messed up. It can be useful, but it's overcomplicated, and there's something much simpler and easier available. Rotations are the Achilles heel of general relativity. Now, in general relativity, Einstein used the gravitational potential, and he claimed that that's what governs the rate that clocks run. So that on a rocket accelerating through space, if we release a photon from a clock above, it will arrive at the clock below with a little bit of increased energy. And Einstein claimed that that increased energy, that change in potential, will change the rate that the clock runs. So that on a rocket undergoing linear acceleration, the clock above will run slightly faster than a clock below, and so on. And I've got 3 clocks, but we could keep stacking clocks forever, so that when you add a clock above, the clock below at the base starts running even slower. And if you add an infinite number of clocks, then the clock at the bottom will run infinitely slowly. If you want a deeper explanation of this, you can look at my video on proving Einstein wrong about the rocket on a tether thought experiment. I'll just go through it briefly. If we put the rocket on a tether, it's going to be accelerating around a very large circle. And if we place clocks at equal intervals all the way around the circle, each one of those clocks, if it emits a photon, will arrive at the clock that's below with increased energy. And Einstein says that that should make the clock below run more slowly, and so on. And if we go all the way around the circle, eventually we come to the clock that's running the slowest is directly above the clock that's running the fastest. No, clearly all of the clocks accelerating around a circle will be running at the same rate. And that's not what general relativity tells us. General relativity is falsified. And furthermore, if we let this tether extend to infinity, the case of the rocket accelerating around the circle becomes the same case as the rocket under linear acceleration. So the clocks on board both rockets will be running at the same rate. When the natural world behaved counter to Einstein's chosen theory, he had to get rid of this pesky behavior of rotations, and that there's only one physical resting frame for rotations, because he felt it undermined his theory. So he hand-waved it away, tried to explain it away through faulty reasoning, and basically ignored what amounts to a law of nature. Now, when a scientist ignores a law of nature and ignores data that runs counter to his theory and continues on anyway, there's a name for that. It's called doing bad science. And we try not to do bad science. Well, Einstein is guilty of doing bad science in the development of general relativity. In his own words, such extension of the theory would have to be thrown out on physical grounds. So that was probably the only one true statement from that paragraph. In 1916, Einstein included Mach's principle as a foundation of general relativity. General relativity is ill-founded and flawed. So until next time, I'm Hugh Manfield.